Now we are facing the question number 4 of 2025 June. So this is about the curve. The curve equation is given, which is 4 cos x. Okay, so we know the cos curve. So what is the max point? So by looking at this, we can have that answer, because let me quickly understand it. So it's gonna be cos x. We know that's in between 1 to -1. So if it is 4 cos x, which is 4 times, it be 1 to -4. So we can see this point is going to be 4, and this point is going to be -4. So these are the main things that we know. And also we know every time the x-axis, when this becomes 0 and stuff. Yeah, anyway, let's go with the question and see what they're asking. According to that, we'll model our graph. They're measured in degrees. Okay, the point x and q lie on the curve and shown. Find the coordinates of P. Okay, find the coordinates of P in the sense the P coordinate is here, where the y value is 0. Okay, so the point P, y equals 0, which means 4 cos x is 0. So in that way, cos x is 0. And we know here the x value is anyways positive, because it's in the positive quadrant. So when you have the cos x equals 0, so we know the base angle is going to be like 90 degrees, because we know the base angle is that, but which is we can take it as theta, but in a quadrant format, we know even this all, so even this is also positive, which is 180 plus theta. This is theta, so usually this goes 180 minus theta. In a degree format, this goes 360 minus theta. So the next positive, like this is the P is this is what that 90 is. We are asking the next next 0th value, which is 180 plus theta. So 180 plus 90, which is 270. So the P coordinates will be 270, 0. So this will be actually 270. Okay, then they're asking the coordinates of y. Y is here, so it's -4. Okay. Now actually, before doing any calculation, since we actually see the whole pattern here, we can easily get the points too. So let's see in such cases, before going for the next one, you can see whether how many marks are given for this question. So it's a 2 marks, so they do expect little bit explanation. Otherwise, we could see it's -90 here, so it will be -90 here, and this will be -180. Anyways, let's do a little bit working for them. So the q coordinate, we know y is going to be -4, so which is 4 cos x is -4, so cos x equals -1. So if we see the principal angle, which is cos inverse 1, would give you 0. Okay, so in that way, similarly for a negative value, since it's negative here, we can easily go with this quadrant, which is this. This would give you 180 minus theta, the very first negative value of cos. So 180 minus 0 still give you 180. So because of that, we know it's the negative angle. We can just get the q coordinate. It's negative 180. Come on, negative 4. So this is the coordinate of the q. It is pretty easy. Now they're asking state the number of solutions of the equation. Okay, for C, what they're asking is 4 cos x equals 3. Okay, if we really forget about the remaining work though, so what we can see is there, no, for the part C, so we know the first one they have said as 4 cos x equals 3. So this is our fx. This is our graph, to be honest. So once you have it, you can feel actually it can be taken from the graph or the numerical method. Let's see what they're recommending. They didn't really recommend anything, so we can go either with anything. So I'll just go with the graph. They're talking about positive 3. So if it is positive 3, we know the graph we are taking is 3 is somewhere here. So the graph, this is y equals 3. So we know in the gap from 0 to 360, they have 2 intersection points in the positive side. Now the question is for this much of entries. Let's try to identify how many paths are there for one. This value divided by 360, how many intervals we have? 50 intervals. If we have 50 intervals, we know these 2 points, the 2 intersection points are repeated in every 50 intervals. So the number of solutions, are going to be that number. So it's 50 times 2 solutions, which is 100. This is the Roman number 1. Okay, now let's do the Roman number 2. So in the Roman number 2, there's a little bit more work, I would say. Okay, we need it here too. Okay, now we are going to the question number 2. So in the question number 2, they are talking about 5 plus 4 cos x equals 1. But here our graph, what we have is 4 cos x, which is 1 minus 4 minus 5, which is minus 4. So literally now in this attempt, what they are asking is 1 minus 5, which is 4 cos x equals negative 4. So if it is negative 4, this is that graph. So let's go back to our question. Let me pick another color for this. I'll go with the green, purple, I guess. Now they're talking about negative 4. If it is negative 4, we know this is what the graph is. This is the y equals negative 4 for the Roman number 2. And this is for the Roman number 1 actually. Okay, so once we have that value here, so how many in the range is going to be negative to this thing? Okay, if we consider a negative 360 up to, how many intersection points are going to be here and here, which are only 2. So we know in the gap of negative 360 to positive 360, we have only 2 intersection points. So if we have 2 intersection points, so if we are extending a little bit more into another 360 here, so we know that here the gap is 360 now. So what they are saying is you are extending it to 0 is here, we had negative 360 and they're extending into negative 70. So here we have 360 and again it's extending to this value. So in such cases we can clearly see there will be a 1 value which is another time exceeding. So it will be altogether 4 solutions. How do you get that? 4 is, we know in that gap it's going to be 2. This is times 4. So this is how we check that value. Because when we repeat that curve, we get another one here, and this curve repeated will be another one here. Yeah. Let's come to the Roman number 3. It's 4 cos x minus 1 equals 1 in the interval of this. Okay. Let's quickly go with Roman number 3. Let me take another color for this, I guess. So it's Roman number 3. Let me only have this. So this time they're asking 4 cos x minus 3 equals 1. So this time the 4 cos x is going to be positive 4. So similarly, if we come back to the question, the positive 4 is this. For the positive 4, we're going to go with, so they're quite similar. So I'll change up the color a little bit. So it would be this, which is y equals 4 for the Roman number 3. So the intersection point is this and this. So this is how you identify, and also there's a point in the right on top as well. These are the 3 intersection points. Okay. Now we know at x equals 0 there's a 1 intersection point, and there are two more intersections which will repeat in every corner. Now they're talking about negative this thing. So we know 0 is there. In a negative 360 to positive 360 there were 1 solution and there was one, so altogether 2 solutions, and multiple repeated to this thing, and 1080. Here it will be negative 720 and this is negative 1080. So we know if we talk about the solutions though, there will be 1 solutions in this range, 1 here, another one here, another one here, another one here, another one here. In the middle also there was a 1 thing. So we could say it's 2 times 3 and the at 0 value, which is 7 solutions. So always solutions in this thing is going to be the value. So this is how we get the answer. So every value. So look at the graph and always try to identify with respect to the graph that you have driven so far. So I think this is quite a better version of a cost curve. Thank you. Hope everything is clear for you. So if not, please do ask questions if you have any doubts. Thank you.